Okay, the Circles 1 study guide. The first four are asking you to identify the lines and line segments shown. For number 1, it is asking you to identify the line AG. This one's going to be a secant because it is intersecting the circle at 2 points, so it is a secant. Number 2, BC. That is going to be a chord. Okay, it goes from one end to the other. It is a chord. ED is a tangent. It intersects the line or the circle at 1 point. PC is from the center of the circle to the edge. That is called the radius. So number 4 is the radius. Number 5, we have AB equaling 24 and PC equaling 5. So what we have here, though, is a right triangle. Now, when this here intersects this here, it is perpendicular, and that also means that it bisects it. So AC equals CB. So if we look for AC, we divide 24 by 2, and we get 12. And now we have a right triangle here. And to find the third side of a right triangle, we use Pythagorean Theorem. So that would be A squared plus B squared equals C squared. A and B is 12 and 5, so 12 squared plus 5 squared equals C squared. We have 12 squared is 144, and 5 squared is 25, equaling C squared. So add them up, you get 169 equaling C squared. To find C, which is AP, you take the square root of 169 and you get 13. So your answer is going to be 13. Number 6. Again, we have a right triangle here. So looking for AP, we're going to use the Pythagorean Theorem again. So A squared plus B squared equals C squared. We have 12 being A squared and 20 being C squared. So now we square both the numbers. So 12 squared is 144, 20 squared is 400. Subtract both sides by 144, you get B squared equals 256. Now to find AC, you take the square root, which is 16. But we're looking for AP, so we got a double AC because remember, if this is perpendicular to this, it's also bisecting it, meaning cutting it in half. So each of these are the same. We double this to give you the full length. So 16 times 2 is 32, and that's going to be 6. Number 7, we have a triangle inscribed of a circle. We have angle C is 55. Now, in this type of situation, we have AB equaling AC, which means angle C is going to be equal to the angle B. So that means angle B is also going to be 55. Because remember, in an isosceles triangle, angles across from congruent sides are equal. So these two are equal. The angles across from them are equal. So that's B and C. To find A, A is 36. Since this is 36, we know these two angles are the same, so we need to subtract 36 from 180 because all three angles add up to 180, and then we divide by 2, and we get 2. So number 8 is 72. For number 9, we have AY is 13. AY is going to be congruent to AX, so AX is going to be 13, so double it, and we'll get 26. And that is number 9. Number 10, it says, is segment AB tangent to circle P? If this is tangent to this circle, then this has to be the point of tangency. And we know that the radius is perpendicular to the point of tangency right here. So this will have to be a right angle. So that means we will have to use Pythagorean Theorem. So if this is the right angle, that makes 6 and 8 A and B, and PA is going to be C. So we have 6 squared plus 8 squared equals 12 squared. 6 squared is 36, 8 squared is 64, and 12 squared is 144. Now we need to see if these two add up to 144. 36 plus 64 is 100. So they are not equal, so it is not tangent to circle P. If these two numbers were equal, then you would say, yes, it is tangent. Okay, and that is number 10. Number 11, we are looking for PA. We are assuming that this is tangent, so that means we're going to use the Pythagorean Theorem. The angle that's going to be the 90 degrees is B, because that's the point of tangency. So now 9 and 15 are A and B, So square them. 9 squared is 81, 15 squared is 225. Add those up, we get 306. You take the square root, round it to the nearest tenth, you'll get 17.5. So PA is 17.5. All right, this one we were looking for AX, which is from here to here. We do not know that, so let's put in a variable. So let's put in X. Okay, now we know if these two are tangent lines, then this here is also X. So these two are the same, these two are the same, and these two are the same. Now if this whole thing is 34, and this piece is X, this piece will have to be 34 minus X. So we write down 34 minus X. Now again, these two are the same. So that makes this 34 minus X as well. Okay? Now, to find this piece, we know the whole thing is 32. We subtract 32 from this piece to give you that piece. So we have to do 32 minus 34 minus X. We're subtracting the entire thing, so you have to distribute the negative. Doing that, we get 32 minus 34 plus X. This becomes positive and this becomes negative. 32 minus 34 is negative 2, so we have negative 2 plus X equaling this piece. So this is negative 2 plus X. Now if this is negative 2 plus X, so is this. So now these two are equal. Now to find AX, we will need to add up each of these pieces. So adding up all my X's, X plus X plus X plus X is 4X, minus X is 3X, minus X is 2X. So we have 4X minus 2X is 2X. Negative 2 plus negative 2 plus 34 plus 34 is 64. Okay, now 28, 32, and 34 is our perimeter, or all our sides add up to the perimeter, each of those numbers. So add each of those up and set it equal to all the pieces, which adds up to 94. So we have 2X plus 64 equals 94. So each of these pieces here add up to 2X plus 64. Each of the numbers here, 32, 34, and 28, add up to 94. Now we subtract 64 from both sides and we get 30. Divide both sides by 2, we get 15. So this X here, or AX, is going to be 15. So that is going to be your answer for this one. Okay, now for this one, we are looking for the measure of AB. Now this one's a little tricky but easy at the same time. Make this piece any number. Literally make it any number but not 0, obviously, because we can't have a 0 side net. I'm going to make it 3. Again, you can choose whatever number you want. We know these two are the same, so if this is 3, so is this. Now these two add up to 18, so this has to be 15. So now these two are 15. Now 26 minus 15 gives you 11 because these two have to add up to 26. Now these two are 11 because, again, they're tangent. Now these two add up to 32, so 32 minus 11 is 21. Now these two have to be the same because they're tangent, so it's 21. Now AB is going to be these two added up, so you'll get 24. Now if you had used a different number, these two will still end up adding up to 24 at the end. Okay? So again, as long as you pick any number larger than 0, you should be fine. Let's look at the next one. So 14. So we have angle A, P, and B equaling 123. We were looking for BC. Now remember, central angles are the same as the arc. This is a diameter here. So that means these two add up to 180. So subtract 180 from 123, we get 57. So my arc is going to be 57. It's a central angle, so these two are the same. If this was inscribed, then it'd be half, but it's exactly the same, so this is 57. Number 15, we have APB equaling 110. We have DC equaling 5x plus 10. Notice these arcs are there. That means both of these equal 5x plus 10. So we write it in twice. Now, since this is a diameter, all three of these add up to 180. So add up 110 plus 10 plus 10 is 130. 5 plus 5 is 10. So 10x plus 130 equals 180. Subtract 130 from both sides, you get 50. Divide by 10, you get 5. So x is going to equal 5 for number 15. Number 16, we have BC equaling, or BAC equaling 25. BC equals 5x plus 30. Now this one is inscribed because it goes to the edge of the circle here. So we know this angle is going to be half of this one. So to solve this for x, double this angle and set it equal to this, because this is equal to this doubled. So 5x plus 30 equals 50. Subtract 30 on both sides, you get 20. 5x equals 20. Divide both sides by 5, you get 4. So x is going to equal 4 for number 16. Okay, number 17. ABD, the angle is 23. Now notice that the arc that it goes with. Mark it like this to see the arc that it goes with. It's inscribed, so this will be half of this arc. Now if you notice, we're looking for ACD. This one goes with the same arc. So that means these two angles are going to be the same. So ACD is going to also be 23. And that's number 17.